This week we will be doing a effective graphs and charts discussion. We will also be doing a week for displaying data. This is where you're going to be using Excel to do bar graphs and other charts and graphs. And then we have our Tuesday night 7 p.m. optional Zoom meeting. Charts and graphs are prepared by nurses, statisticians, almost business, everything. It gives a visual representation of what the data actually says. So it's not just numbers, but it's also a visual representation of exactly what's going on. But it can show things like upper and lower limits. It can show basically whether the data is valid enough to run a certain test. There's lots of reasons why it is valid and reasonable to do a chart or a graph. And we're going to be doing a few of them here, and in a couple of weeks, we're going to be doing some more. So understanding your value in this is very, very important. Bar charts. The picture on the right is a bar chart. You'll see that there's bars, there's numbers on both sides, there's labels. Those labels are years and number of mango trees. The x-axis is the horizontal line, and you'll notice the years there. They're most of the time on the x-axis is going to be a chronological, and then your incremental changes are on your y-axis. So years 2005, 6, 7, 8, and the number of mango trees on the horizontal line chart. For the line chart, you'll see that there's a line, and sometimes there's a dots, and sometimes there's not. You can put all these in there in Excel or SPSS. We're using Excel in this class, but you notice that the x-axis again is incremental by not only years but also months this time, and then the incremental sales in thousands goes up on the y-axis, and this is a line graph, line chart. Histogram. Histogram is a representation of a set of data, the actual points. So you see the bars, and the bars tell you, in this case, time and count. Could be anything. But what it does is it says in let's say that in the 60 range there was 200 or a little over 200, and you go to the 100, which is the middle or the mean number, which is almost 1,000. Now you see the curve line. The curve line shows you whether you have a bell-shaped curve. You have a good normal distribution. And it's very important that your data have a normal distribution, or you have to run different tests. Not getting into that today, but will later. The shape of the histogram is extremely important. Okay, as you can see on the left-hand side here, it's a systematic, but this is your normal distribution. You see like one mountain. That's the best way I would say it. But the mean, mode, and the median are equal. Now, getting a perfectly normal distribution is extremely hard, so there is a little bit of variance to it. The right skewed, which means the mode, the median, and the mean. Okay, where this would still be the center, but the mode is higher than the median, and you can actually visually see it. It'll be slid to the right. Be slid to the right. Okay, left skewed or negative skewed. This is a positive skew on the right side. This is a negative skew on this side, and this is the same thing. The mean is more to the left, to your left hand, and your mode is toward the right. But you'll be able to actually see that when you look at data. Scatter plot. Scatter plot is generally used in a correlation. It's a relationship between two variables. So this one is process input and quality characteristics XXX, whatever XXX is. You'll see that the dots are all placed in there. Those are all data points that are placed in based on whatever the data is on. So it's basically quality characteristics. The other part would be process input. The x-axis is your process input, and the y-axis is your quality characteristics. Okay, so this is what a scatter plot actually looks like. Remember, it's a relationship between two variables in a correlation. In analyzing the scatter plot, I'm going to give you just a little bit of a tidbit so when we do correlation, it will make more sense. The dots you saw in the last one were just kind of placed there, but now if you put in a best fit line, which the best fit line would be in direction of which direction the dots are going. So you can see the positive correlation. You'll see that it's going up. So basically in this side, whatever the two variables are on the outside, on the x-axis and the y-axis, they're both going up. So as study goes up, scores go up. In negative correlation, you'll see from the y to the x, it's a downward slope. And that downward slope is because one is positive and one is negative. So as anxiety goes up, test scores go down. And then as you look at the one that says no correlation, this would mean that there is no correlation between any of them. The line would be straight across right in the middle. So positive would go up, there would be a downward slope for negative, and if there's no correlation, the dots are all the way, and the line would be right through the middle, straight across. And that would mean that there's no correlation between them. There's actually no relationship at all. Thank you.